Alright, boys and girls, today we are looking again at Chapter 3, Section 1. It's the last time we will look at it, and we'll be doing graphing a linear equation using a table, which you should already know how to do. We've done it before. And then we're also going to look at graphing a linear equation using intercepts, and this will be a little new to you, but I think it's pretty easy. So make sure you got your goal sheet filled out, and let's go ahead and get started. So first, a quick refresher. We're going to create a graph using a table. We've got our equation here, y equals 2x minus 3. And if you recall, a table looks like a T. We've got our x's and our y's. Now remember, we get to pick the y values that we want to choose. You must use some negative and some positive. Can't get away with that. So typically I recommend students choose -2, 0, and 2. You could choose -1, 0, 1, but this way we choose some values that are a little more spread out and we can see more of the graph. So then, if you recall, we're going to take each of those values and we're going to substitute in for x to find out what y equals. So the first value we're substituting in is -2. So that means we're doing 2 times -2 minus 3. 2 times -2 is -4, minus 3 is -7. Then we're going to substitute in 0 in for x, and that's going to be 2 times 0 minus 3. 2 times 0 is 0, minus 3 is -3. Then we're going to substitute in 2 for x. So we've got 2 times 2 minus 3. 2 times 2 is 4, minus 3 is 1. Now we have our ordered pairs. Remember, ordered pairs go x, comma, y. So I'm going to make a quick list of my ordered pairs so you recall. I've got -2, comma, -7. That's my y value and my x value. I've got 0, -3. And I've got 2, 1. When you're graphing, remember you're going to go to the x first. That's your horizontal. So I'm going -2, -7. And there's my first point on my graph. And then I go 0, -3, and there's my second point, and 2, 1. There's my third point. We're going to connect those guys with a nice straight line, and don't forget your arrows on the end. Ooh, those arrows are a little fat. Let's fix that. Oh, that looks way better. Beautiful. So you've just created a graph using a table. Now, sometimes our graphs are a little bit more difficult than that. Oh no, I didn't insert it. Alright, well, you guys have witnessed my first screw up. It's been recorded. I forgot to insert a slide. Well, it's here now. Alright, so let's continue. We're graphing by making a table first. Now, this example, you'll notice, has a fraction. And it's a little bit more difficult to graph making a table, but you can do it, I know it. The important thing is that you select values from the domain. Remember, the domain is the x value. And when you're selecting them, keep in mind that you should pick numbers that are multiples of the denominator, because that x coefficient, or the number in front of x, is a fraction. Alright, so our x values, the domain, we're going to choose as multiples of the denominator. Our denominator is 3, so our x values are multiples of 3. 0, 3, 6, 9, 12. Got to pick some negatives, some positives. So by doing that, we are assuring that the points that we get on our graph will all be pretty positive, even numbers. So, first one that we are working on is -3. Same thing as last time. We're going to substitute in for x. So we've got 1/3 times -3 plus 2. 1/3 times -3 is -1. If we add 2, that'll give us 1. That gives us the ordered pair of -3, 1. Notice the fraction disappeared. We've got a nice, pretty point that we can graph at -3, 1. Let's do the same for 0. 0 times -3 is 0. Plus 2 is 2. So we've got an ordered pair of 0, 2. That's going to go 0, 2. Plug in a 3. 3 times 1/3 is 1. Plus 2 is 3. So it gives us the point at 3, 3. Graph it, 3, 3. Things are looking good. They're making a nice line. Plug in a 6. 6 times 1/3 is 2. Plus 2 is 4. So that's the ordered pair, 6, 4. And we can put that one on our graph as well. Connect it with a beautiful line. A little crooked there, but you get the idea. Arrows on the end. Alright, moving on. As a refresher, a little oi voo for you. If you recall, we talked about this a little bit yesterday. We've got oi, which stands for H, horizontal, horizontal. The O stands for 0, as in 0 slope. And then the Y is a Y equals, or that's how the equation is written. And then we've got VOOX, which stands for, anybody remember? V stands for vertical. It makes a vertical line. And that vertical line has an undefined slope and is written as an x equals equation. So if I were to try to graph y equals 4 or x equals -2, I can keep in mind this saying, oi voox. So in going to graph y equals 4, let's start with that one. If I were to make a table of x and y values, the equation itself tells me that y will always equal 4. No matter what x value I choose, y is always going to be 4. So if I graph those points, alright, let's go ahead and graph those points. If I go -2, 4, -1, 4, 0, 4, and 1, 4, you notice that by connecting these, I'm going to get a horizontal line. Oops, that's a little ugly. Let's try that again. A little better. It's still not great, but you get the idea. So y equals 4 gives a horizontal line going through 4. Let's graph x equals -2. Using a table, x equals -2 means the x value is always going to be -2. Any y value that I want can come out. Notice I'm just picking random numbers. When I graph this, we're going to be able to see that it's going to make a vertical line because it says x equals. So we go -2, -2, -2, 1, -2, 3, -2, 5. And so in this case, the x value is always equal to -2, and we get a vertical line. Now, do you have to make a table to be able to make the graph? No. You should be able to use these hints of oi vooks in order to skip making the table. But you do need to understand where those values come from. All right, moving on. Now this is the second part, the part that I said would be new to you. Making a graph using intercepts. It's really important that you recall what we talked about yesterday. Remember, we said that all x-intercepts, hold on a second. All right, all x-intercepts have a y value of what? Do you remember? A y value of 0. And do you remember about y-intercepts? All y-intercepts have, anybody? All y-intercepts have an x value of 0. Anybody remembered that? Good for you. All right. So we're going to go ahead and try to graph 2x plus 4y equals 16 using intercepts. So the first thing we're going to do is find our x-intercept. And we're going to use the piece of knowledge that it has a y value of 0. So if y equals 0, I just need to figure out what x equals. So I can plug in 2x plus 4 times 0 equals 16, and now I can solve for x to find out what that x-intercept is. So 4 times 0 is 0, so I get 2x plus 0 equals 16. Plus 0 doesn't do anything. I've got 2x equals 16. So x equals 8. My x-intercept is 8. This is going to go a little bit off my graph here, but you get the idea. Now to find the y-intercept, I'm going to use the idea that x equals 0. So in my same equation, instead of x, I'm going to plug in a 0. And now I solve for y to find the y-intercept. So 4y equals 16, divide by 4, and y equals 4. So I'm going to put that point on my graph on the y-axis at 4. I've got my 2 points. 2 points is enough to make a line. Draw that line, add some arrows on the end. You are good to go. Wasn't that quick? A lot quicker than making a table. All right, let's try another example. Y equals negative x minus 5. Okay, so same thing again. First, let's start with finding the x-intercept. So y must equal 0. So 0 equals negative x minus 5. Add 5 to both sides. 5 equals negative x. That's a negative 1x. Divide both sides by negative 1. So that means that x equals negative 5. I've got an intercept of x, negative 5. Alright, and now for the y. Y-intercept has an x value of 0, so 0 equals, y equals, not 0 equals. Y equals negative 0 minus 5. We know the negative 0 is just 0, so y equals negative 5. So we've got our other intercept at y equals negative 5. Connect the dots, and you've got your graph. Easy enough. So homework tonight, guys, page 160. You're going to do the first set with a table, like in the first examples, the second set with intercepts, like in the last example. Good luck and have a good night.